finite intersection property. So we are going to discuss about the finite intersection property. So definition, let us first define what this means. Definition. So let this be a collection of subsets, of topological space X. Let that be a collection of subsets of X, comma. Then this set consisting of a collection of subsets of X, this set has a finite intersection property, if it has a finite intersection property if for every finite subcollection, if for every finite subcollection of subsets, if for every finite subcollection this from the set, is for every finite subcollection this from this set, comma, the intersection of these elements, from I equals 1 up to n ci is not an empty set. So we say that a collection of subsets of X has a fifth property if for every finite subcollection of elements from that collection, the intersection of those elements is actually not. I think now we can discuss some examples of this fifth property. So we are going to consider what examples. Let x equal to r. With the usual topology, the usual top, and a is that set. So we are going to consider the collection. Consider the collection. Collection of subsets. Of A. So we are going to consider that collection. This one. It has subsets of this interval. All of these sets here are subsets of that interval. We also have 2, 3, 1, etc. There are many subsets. How am I constructing these subsets? If you look at the way how I have structured this, I'm actually considering this. I'm considering 1 minus 1 over n, then 1. Subsets of this set will always have this looking. So you substitute n equals 1, you will come up with that set. N equals 2, you will come up with that set. N equals 3, you will come up with that set. So you continue in that way. Now observe that this collection here has the finite intersection property. Why are we saying that it has a finite intersection property? You take an arbitrary finite subcollection from this and try to compute the intersection. If every finite, you take a finite subcollection of sets from this. We can take consider this one 0, 1. We can also take this. Try to compute the intersection of these sets here. Try to compute their intersection. So you realize that I have 0 there, I have 1 here, I also have a half is somewhere around here. So 0, from 0 to 1, this is the interval from 0 to 1, then a half to 1, it's actually this one. So you realize that the intersection here, intersection is equal to a half 1. So this collection here has a finite intersection property. So that is the finite intersection property.